Hi, everyone, and welcome to Module 3, Lesson 3, where we're going to go over ionic nomenclature. Now, these notes, I'm going to jump back and forth because I want to do all of naming first. I want to do naming, then writing, naming, then writing. So you'll see, just bear with me as I flip through a little bit. So we're going to talk about ionic compounds in this lesson. And we're going to start with the very basic ionic compounds, binary ionic compounds. Now, an ionic compound is a compound that's formed when a metal bonds with a nonmetal or a cation bonds with an anion. So we have something positively charged with something negatively charged. There are many different types of ionic compounds. There are three big groups that we're going to talk about. So first, we'll do the very simple ones where we name simple binary ionic compounds. So literally, all you do, name the cation, name the anion, change the ending to IDE. So if we look at NaCl, Na is sodium, Cl is chlorine, change the ending to IDE. That's going to be sodium chloride. Looking at the next one, Be3N2, name the cation, beryllium, name the anion, nitrogen, change the ending to IDE. Nitrogen turns into nitride, so it's beryllium nitride. SrF2, Sr is strontium, F is fluorine, and so we change the ending to IDE, it becomes fluoride. Aluminum, well, I almost just said the name, AlCl3, Al is aluminum, Cl is chlorine, we change that to IDE, it's chloride. So that's how you name something that has just a cation and an anion, nothing special about it. Now let's go, I'm going to flip to the next, not the next page, the page after that, to write them. So how do we write these simple binary ionic compounds? So takes a cation, write the symbol with its oxidation state or charge. Then I write the symbol for the anion with its oxidation state or charge. And then what I'm going to do is I'm going to take the charges and swap them, and they become the subscripts. Now, with ionic compounds, we can reduce if possible. So let's go over a couple of examples. Aluminum oxide. Aluminum is Al. It has 3 valence electrons. So my options are either to lose 3 or to gain 5. It always does the thing that's less. So aluminum is going to lose 3. So it becomes a +3. Oxide is oxygen. Oxygen has 6 valence electrons. It gains 2 when it becomes an ion. So I have aluminum +3, oxygen -2. Okay. It's important to note that the positive thing always goes first and then the negative thing. And so what I mean by drop and swap, this charge, that 3 coming down here, this is coming down here. So my formula for aluminum oxide is Al2O3. Okay. Another way to look at it is, okay, if I have aluminum, that's +3. I have oxygen, that's -2. I need the charge, compounds are neutral. So I need the charges to add up to be 0. Well, right now I have a +3 and a -2, so that overall is +1. So let me add another oxygen. Okay, so now that's -1. So I'm going to have to add another aluminum, which is +2. When I add a third oxygen, my charges now equal 0. I've got 2 aluminums, 3 oxygens, Al2O3. Now, when we're writing these formulas, we want to make sure that subscripts look like subscripts. So if you choose to use a word processor, you have to make it a subscript. So it's super important that you do that for your final answer. And at first, I want to see you swapping them, okay? Nobody is that good initially that they can just do it without swapping them. I want to see that, okay, at least in your homework, because this is something that is so easily Googleable, it's not even funny. Okay, lithium nitride. So lithium, Li, it loses 1 electron to become an ion. Nitrogen will gain 3. I take them, I swap them, and now it becomes Li3N, lithium nitride. And then strontium phosphide, strontium Sr. Strontium has 2 valence electrons, so it's going to lose 2. Phosphorus has 5, it's going to gain 3. I go ahead and I swap those, and it's Sr3P2. So that's naming simple binary ionic, writing simple binary ionic. So now, and again, if you need to pause the video, please do. We're going to go back and talk about naming ionic compounds with transition metals. You may have noticed initially when we talked about finding the charge when things become an ion, transition metals were left out because transition metals can have multiple oxidation states. So it's not just like copper is always +1. Copper could be +1 or +2. Iron isn't always +2. It could be +1, +2, or +3. So transition metals have multiple oxidation numbers. There are exceptions though. There are exceptions to this. Aluminum is always +3, so we don't need Roman numerals. We're going to talk about that. Zinc and cadmium are always +2. Silver is always +1. This is important. Aluminum, always +3. Zinc and cadmium, always +2. Silver, always +1. So those are transition metals that break that rule, okay? Those are always the same thing. So we'll talk about those Roman numerals in a second. But keep that in mind. Okay, so naming ionic compounds with transition metals. So name the cation, simple. Transition metals have multiple oxidation states, so you must include the oxidation state as Roman numerals in parentheses. Name the anion and change the ending to IDE. First off, Roman numerals. You have to, 1 through 6 will probably do it for you. In case you don't know, 1, 2, 3, IV is 4, V is 5, VI is 6. So those are your Roman numerals. So if you weren't aware, 1, 2, 3, 4, 5, and 6. Okay. So name the cation. Cu is copper. After that, you put a set of parentheses immediately. If you're typing this out, there is no space in between copper and the parentheses. Is that important? Not particularly. It's just what the rule is. Then we name the anion and change the ending to IDE. We know chlorine turns into chloride. Now we have to figure out what is the charge of that transition metal? What is the charge of that copper and what goes in that parentheses? So to do this, we work backwards. Ask yourself, okay, I don't know what the charge of that copper is, no clue. I do know the charge of chlorine. Chlorine's -1 when it becomes an ion. So what I'm going to do is I'm going to switch them, and I get CuCl question mark. Ask yourself, what does that question mark have to equal to make this thing and this thing look the same? That answer is a 2. That means copper is a +2, and so therefore the Roman numeral must be 2. So it's copper 2 chloride. That is the correct name. Roman transition metals always need Roman numerals, okay? I have to clear this just because I don't have any more space, so pause if you need any of this. Okay, next one, MnO2. Mn is manganese. Please be careful, it's not magnesium. Magnesium is Mg. Put my parentheses for where my Roman numeral is going to go. O becomes oxide. I'm going to work backwards. I do not know what the charge of the manganese is. I know oxygen's a -2, so I'm going to swap those. I'm going to Mn2O question mark. Now, what does that question mark have to be to make this thing and this thing the same? Now, this one's a little tricky because we have to reduce, okay? This question mark is actually a 4. So I'm going to put an IV there, and this name is manganese 4 oxide. Why is it a 4? Mn2O4, I can reduce that. We only reduce ionic compounds There is no talk of reduction in the first video. We only reduce ionic compounds if we have something that can be reduced. Mn2O4 can be reduced to MnO2, and now those two things are the same, and so this is manganese 4 oxide. This is one of those trickier things that's going to come with practice. I'm going to do the last one over here on the left. I've got copper, Roman numerals, and then oxide. Okay, so we have to figure out what those Roman numerals are. So, same thing. I have no idea what the charge of that copper is. I do know that oxygen's -2. And when I switch those, I get Cu2O question mark. Now that question mark has to be what? To make this thing and this thing the same. That question mark has to be a 1. Because then it would just be Cu2O. So this is copper 1 oxide. That's it. That's naming them. So naming them is a little more difficult because you have to figure out that Roman numeral. Writing them is easier because it tells you the Roman numeral. So to write ionic compounds with transition metals, write the symbol of the cation. The Roman numeral in parentheses will tell you the oxidation state. Write the symbol of the anion with its charge, drop and swap. Remember to reduce if possible. So copper, 1, so that's +1. Chlorine, -1. Switch them, we get CuCl. That's copper 1 chloride. The next one, chromium, Cr. Vi is 6, oxide -2, right? We go ahead and we swap them. We get Cr2O6. If you wrote that, it would be incorrect because we must reduce. So Cr2O6 turns into Cr O3. That would be the correct formula for chromium 3 oxide or 6 oxide. And the last one here, scandium 3 bromide. Scandium, Sc, the charge +3, it's telling me. Bromide, Br -1. We go ahead and we swap them. You get ScBr3. That's it. Okay, so again, this is a little easier because it already tells you the charge of that transition metal, so you don't have to figure anything out. Okay, I'm gonna clear this. And then we have one more type left, and that's naming ionic compounds with polyatomic ions. Now, hopefully in module 3, lesson 1, you were to already have looked at the polyatomic ions and started memorizing them. This is going to be so much easier once you know those polyatomic ions. But a polyatomic ion, as a brief introduction, is just a group of covalently bonded molecule or covalently bonded molecules that have a charge, and therefore they can be in an ion. So if you ever see more than 2 elements in a compound, it's going to have a polyatomic ion. Okay, so it's very simple. Name the cation, name the anion. If you have a polyatomic ion, you do not change the ending, no matter where it is. So if we look at the first one, NH4NO3 has 2 polyatomic ions in it. NH4 is ammonium. NO3 is nitrate. So you're simply writing out the name of them. And this is easy if you know what those polyatomic ions are. So MgSO4, 2 things here. So the first part's just simply magnesium. And then SO4 is sulfate. If you don't have them memorized at this point, you should have the list out by you, your flashcards by you, so that you can go through them and actively look, and that will help you remember. The next one, Al, we know is aluminum. PO4, polyatomic ion, phosphate. Okay, and finally, NaC2H3O2. Na is simply sodium. C2H3O2 is acetate, so that's sodium acetate. And again, the more you become familiar with these, the simpler it's going to be and the faster you're going to be able to do this. So I'm going to clear this and we'll talk about writing ionic compounds with polyatomic ions. Now, to write them, it's a little bit different. Write the symbol with the cation of the cation with its charge. Write the symbol of the anion with its charge. We still swap them. Here's where it's different. If there will be more than one polyatomic ion, it needs to be put in parentheses. I'll show you what that means. So write the symbol with its charges. Ammonium is NH4 plus 1. Sulfate, SO4 negative 2. Again, this will be easier the more that you understand what these polyatomic ions are. What I'm going to do, take them and swap them. So now you see we're going to have two ammoniums. So the NH4 needs to go in parentheses. So I have two NH4s and then one sulfate, SO4. So it's parentheses, NH4, close that parentheses, 2, SO4. And it's very important that we do that because I have two ammoniums, all right? I won't have 2 nitrogens, 8 hydrogens, and then a sulfur and 4 oxygens. I have 2 NH4s. So next one, magnesium chlorate. We take magnesium plus 2, chlorate, ClO3 minus 1. And we go ahead and we swap them. And then I'm just going to write it up here. I'm going to have 1 magnesium. I'm going to have 2 chlorates, so it needs to go in parentheses. And then finally, calcium phosphate. Calcium's plus 2, phosphate negative 3. We swap them. Ca3, parentheses, PO4, close that parentheses 2. The only thing that goes in parentheses is polyatomic ions if you have more than one of them. Please don't put it in parentheses if there's just one. If there is more than one, then it goes in parentheses. Okay, so right now, I'm going to clear this, and I want you to pause this video and do these 8. I'm going to, like, you got to pause it. I'm going to write out the answers. Pause it, or don't. It's going to take me a while, whatever. I'm going to write out all the answers, check your work, and then I'm going to move on. Again, if you have questions when you come back into class, please ask them. Clearing this, writing out the answers. Don't forget to reduce. Fe plus 3, sulfur minus 2. Calcium, I'm going to have to write it down here. Calcium plus 2, phosphide, P minus 3, Ca3P2. And then finally, magnesium, perchlorate, ClO4 minus 1, swap them, Mg, parentheses, ClO4, 2. Okay, there are all of your answers. They're a little all over the place here. But again, if I'm doing drop and swap, you should be doing them. So it just make sure that you're getting it correct. Something to point out, if you look at your list of polyatomic ions, they almost all end in ate or ite. There are a couple that end like ammonium, but most of them end in ate or ite. Okay. If you see something that ends in IDE, it is almost always, there are a few exceptions, there are polyatomic ions that end in IDE, but if it ends in IDE, you're almost always going to be the element. So keep that in mind until you know all of your polyatomic ions. Okay. clear this. One more thing to talk about, and that's acid nomenclature. Now, there are many acids that we're going to see. You probably already have seen them. So being able to name them is extremely important. There are two types of acids, those with elements and those with an oxy-ion, which is a polyatomic ion that contains oxygen. All acids begin with a hydrogen ion. All right, so if you see something that starts with a hydrogen ion, it's an acid, obviously, except water. Now, these are easy because they're done just like ionic compounds, and that's why I group them with them. So to name them, when we just have hydrogen with an element, the prefix is always hydro, and then you have the root of the anion, and then it ends in ic acid. So I is iodine. So we have our prefix hydro. Iode is the root, and then we add ic acid. So HI is hydroiodic acid. Okay, very simple. And then HBr, Br is bromine. So we have hydro. Brome is going to be the root, just like iode was ic acid. So hydrobromic acid. Pretty simple. To write them, it's even easier. Start with, so you see the word acid in the name, start with a hydrogen ion. Look for the root. So this is going to be chlor, which is chlorine. Give it its charge, swap them, hydrochloric acid's HCl. Hydro, when we see the word acid, H+, the root is fluor, that's going to be fluorine. Switch them, BHF. Super simple. Now, oxyacid. So basically, when we have a polyatomic ion. So all we're doing is changing the ending. So you see, you're going to have hydrogen with a polyatomic ion. All we're doing is changing the ending of the polyatomic ion. So if the polyatomic ion ends in ATE, it turns into an ic acid. ITE turns into an OUS acid. So in HNO3, we have nitrate. The 8 turns into an ic acid, and this would be nitric acid. HNO2, nitrite is the polyatomic ion in there. That turns into nitrous acid. Okay, H2SO4 is a little bit different. That's sulfate. The 8 turns into an ic acid. It's actually sulfuric acid. It's a little bit different, not too crazy. And then H3PO3. PO3 is phosphite. And this turns into phosphorus acid. So sulfate and phosphite, a little bit different. Okay. And then finally, how do I write them? Same thing. You see the word acid, it always starts with an H+ in front, and then you have to find the polyatomic ion. So acetic acid, that's going to be acetate, which is C2H3O2, -1. We swap them, and it gets HC2H3O2. Perchloric acid, that's going to be the polyatomic ion perchlorate, which is ClO4, -1. We know hydrogen's +1. We swap them, and we get HClO4. Sulfurous acid is going to be sulfite. Sulfite is SO3, -2, H+ in front. We swap them, we get H2SO3. Phosphoric acid is phosphate, PO4, -3, H+, in front, swap them, H3PO4. Okay, it's that simple. The only reason why this is going to be challenging at first is if you don't know those polyatomic ions. Okay, so that's it for this lesson and this module. That's it for the notes. okay? Very simple, very short, very important. We have to make sure we can do this backwards and forwards so that we can go forward writing the correct formulas, saying the correct names. Okay, as always, make sure you ask your questions, and I'll see you in class.